I don't know if any of you guys have ever worked really long and hard on something and then lost it, but that's apparently what's happened to me today. I had the notes for freezing point depression on page 324, and I had them so perfect for today, and they've managed to disappear somehow into the vacuum of time and space. So it looks like today is going to be a short lesson. Yay, you sad for me. And we'll pretty much exclusively be talking about 12.16. Um, so freezing point depression, there's two example problems, and then I would really like to give you the opportunity to review molality and molarity tonight, because tomorrow we're going to have a review for a quiz on Thursday over this stuff. So use today as an opportunity with the light workload um, to get some of your jazz together with molarity and molality. But let's see how much I remember from my notes. Freezing point depression, um, also known as what happens when you leave your AC in your house too high and then you wake up and you're too cold to get out of bed. Um, freezing point depression. So, what is this talking about? So, freezing point depression is a lot like boiling point elevation. We said that the more crap you add to a solution, the harder it is to make it boil and the higher that boiling point has to be. Because all that crap in the water is keeping it from escaping. Well, it's sort of the same with a freezing point. If you took a glass of water and dumped a whole bunch of salt into it, left it outside in the snow, and then you took another glass and just put a glass of water out there, which one's going to freeze first? The one that doesn't have salt. Why? Because adding a whole bunch of crap to water, or really anything, makes it harder for it to freeze. So, how we'd explain freezing point depression is the change in freezing caused by solute addition. Or, and this is the more important one, solutions have lower freezing temps than their pure solutes. In other words, stuff mixed together takes longer to freeze than stuff taken apart. That's really the simplest way possible I can put that. So we had the boiling point elevation. If you understood that, fantastic. You also understand this. It literally has the same equation. So the change in freezing point equals your new freezing point minus your original freezing point. And guess what this thing is called? We have this thing called Kf, and that's called the molal freezing point constant. Remember, we had the same thing, but it was the boiling point constant? Hey, it's literally the same thing. And guess what? We have this really magical equation. I don't know if you've seen it before. The change in freezing point equals the freezing point constant times molality. Oh, that looks literally just like we did yesterday, because it is the same thing, but instead with freezing points. So, I'm going to do these two problems, and then we're going to call it quits for today. Hey, the whole intro, and it's only under 5 minutes. Let's do it. So, page 324 on 12-11, the example problem. It asks, how much will the freezing point of phenol change if 4 moles of naphthalene are dissolved in 2 kilograms of phenol? And then it goes on to tell us a bunch of junk about naphthylamine that we're not really interested. It just basically tells us that it's at STP, which is great. So, how much will the freezing point change if we have all this jazz happening? So, it tells us we're looking for the change, right? So we're looking for the triangle. Triangle is for change. Then it tells us we have moles and kilograms. What do you know that uses moles and kilograms? It has to do with molality. So moles per kilograms. We have moles and we have kilograms. So we have our M. It looks like it's 4 over 2. Great. Now all we're missing is our constant. So where are we going to get our constant? Hey, guess what? It looks like they give it to us in a handy dandy table. Hooray! So it says, what is the molar freezing point constant? I don't know, for phenol? Hey, that's the problem. 7.40. How convenient is that, guys? Wow. Just the blessings keep pouring on out. So, there we go. It looks like all we have to do is multiply. So, I can simplify this. What's 4 divided by 2? It's just a 2. So what's 2 times 7.40? You might be able to do that in your head. 14.80. And it's asking how much will it change the freezing point? It looks like it's only going to change by 14.80 degrees Celsius. It's not asking for the new freezing point, it's just asking how much did it change. Oh, that's nice and dandy. Let's do the next problem. And I'm out of space. Let's flip the page. So next page we have example problem 12-12. It says, ooh, this one's a bit of a doozy. 12-12. It says compare the freezing points of a 3 molal calcium chloride solution and a 3 molal sodium chloride solution. Okay. So what the heck are we supposed to do here? So, step 1. For this type of problem, you have to do it piece by piece. So, remember when I said that when you're working backwards with molal, you have to end up multiplying by the amount of parts it has, which is confusing, and it's hard to tell when you do it, but I'm going to tell you when you're supposed to do it. Yeah, I think we all remember that from yesterday. So, let's look at calcium chloride. You could have started with the other one, I don't care. So for calcium chloride, when this ends up breaking apart, how many pieces do you have? You have 3 pieces. So your 3.00 molal is going to be multiplied by 3. So you're going to end up with 9 molal. So now we have to do our little equation. The change in freezing point equals the freezing constant times M. We have our M. Now we just need to figure out what our constant is. What is this for? This is for this is a solution. Ionic compounds. It looks like we are using the freezing point of water for some reason. Remember when I said there were some things in this book I'm not a fan of? This is one of them. It didn't even tell you. It should have told you in water, but it didn't. So the freezing point of water is 1.86 degrees Celsius. Then you multiply these and you literally get your answer. It is that simple. 9 times 1.86 gives us 16.7 degrees Celsius, okay? So that's for the calcium chloride. Let's do it for the NaCl. Breaking this apart, how many pieces do we have? I have an Na and I have a Cl. So I'm going to multiply my 3 molal by 2, and I get 6 molal. So now I have that. I can plug it into my equation. I'm looking for my change in temperature because it asks me to compare the freezing points, so I need to find this. My M looks like it's going to be 6.00 M. And then my freezing point, I'm still dealing with water, so 1.86 degrees Celsius. When I multiply these out, I end up with my change in freezing point is 11.2 degrees Celsius. Okay, so I found the change in freezing point for this one and the change in freezing point for that one. So what does it ask me to do? Compare the freezing points. So let's do just that. What's the freezing point of water? The freezing point of water is 0 degrees Celsius. So how would I compare these two things? Which one would take longer to freeze? So if I did 0 minus 16.7, why am I doing this? Because to find this, you must subtract the new from the original. So I end up with minus 16.7 degrees. If I subtract these, I end up with negative 11.2 degrees Celsius. So which one is going to take longer to freeze? It looks like it's calcium chloride. And that's it. By how much? About 5 degrees and some change, right? So when it says to compare, you want to basically say which one is going to take longer. This one would. This one has to be at a lower temperature. And record time, that's all I've got for you today. So again, please study, why am I holding my hands up like this? Please study molarity and molality. I'm going to have on the quiz on Thursday a problem like this, but broken up into pieces. I'll do step 1 and then step 2. So don't really stress about that. So that freezing point depression is important for you to know. We also use that in college chemistry lab. Let's see. Let's do for homework just 2 problems. Let's make it light today because we were kind of heavy yesterday with that math. The only thing I want you to do is for 12C section review, problems 3 and 4. That's it. And please have those ready for me by tomorrow, which I'm recording this on Monday, so tomorrow would be Wednesday. But with that, again, I'm praying for you guys every day. Reach out if you need help, and I will see you soon. Bye.